Today's video will demonstrate how to implement the visitor design pattern. Hello, I'm James Helfrich. Many people find the visitor design pattern to be perhaps the most difficult to understand of all the object-oriented design patterns. I'm going to do a quick demonstration to illustrate how to implement the design pattern on a simple code base. We're going to start with a simple program that has apples, oranges, and plums. Now, the client is going to have a collection of apples, a collection of oranges, and a collection of plums, and there's one of each. And I want you to notice that the apples, oranges, and plums have a completely disjoint interface. So when I initialize the apples, the client has to know about the apples, oranges, and plums, of course, and it's going to fill my fruit basket by calling the unique interfaces apples.set, orange assignment operator, plums.purchase, all completely disjoint. When I count how much fruit I have, I'm going to apples.total, oranges.num, and plums.guess, true or false. Once again, a completely disjoint interface. When I have lunch, I'm going to consume my fruit in various different ways. And of course, when I display them, they're all going to be completely disjoint. And that's because apples, oranges, and plums have nothing to do with each other, requiring the client to know details about each. So let's take a look at the code. So here's my apples class. I have a display function, a set function, a totals function, and I'm going to use a map because I can have many different types of apples. Oranges is only one type of orange, and I'm going to have n of those. And once again, I have the assignment operator. I have output rather than, of course, display, and they're not related by inheritance or anything. And my plums are completely different. There's only two types of plums, Japanese and European. So I'm going to have num Japanese and num European. I can purchase them or eat them or find out how many I have with a get. And notice how that the client, in this case, main, is going to have to know details about each one of these. So what we really want to do is decouple the specific types of fruit so that the client doesn't have to be aware of each of these details. And we're going to use the visitor design pattern to do that. So I'm going to have my initial class diagram with apples, oranges, and plums. And the first thing I'm going to do is create a visitor class. And this is going to be the message. And it's going to have three methods: visit apples, visit oranges, and visit plums. And these are pure virtual functions, as you can tell by the equals 0, which makes visitor an abstract class. Now, after I create this class, I'm going to create a visitor display, which will handle all the display communications, and this derives off the visitor. I'm going to have a visit count, which will count the number of fruit I have, the initialize, which will fill my fruit basket, and eat, which will allow me to consume. And each of these are going to represent different actions or different messages I want to send to my three different classes, apples, oranges, and plums. So let's do that. Okay, so the first thing I'm going to do is I'm going to create a visitor class. Okay, so I've created my initial visitor class, and this is going to be an abstract class because I have pure virtual functions. I'm going to say class visitor, and then here are my three different types of elements I want to visit: apples, oranges, and plums. So I'm going to pass an apples as a parameter, an oranges as a parameter, and a plums as a parameter. Now, right now, the program will compile, it will work. I want to try to find little bite-sized chunks, the smallest amount of work I can do for each iteration, because I never want to have my program be in a non-functional state. So right now, I am good to go. Now, observe, I put this above the apples class because eventually I'm going to have a connection to this in my apples class. But now I want to implement my concrete classes, my visit initialize, and so on. So let's do that work. Okay, at all points in time, I want to do the smallest amount of work possible to make sure everything still works. So now I have a single derived class based on my base class of visitor. I've implemented them, and right now they do nothing. So let's do each of these in turn. I want to initialize my collection of apples, initialize my list of oranges, initialize my list of plums, and I'm going to take that from this code right here where I fill my fruit basket. Okay, at this point in time, I haven't really changed any code yet. I haven't hooked anything up, but now I can initialize my apples, my oranges, and my plums. So let's do that. And now everything works exactly as it did before. I now initializing with my visitor rather than explicitly. All right, let's do the same thing with my other three types of visitors. Okay, observe how the each implementation is completely different because plums use a different method of display than oranges do, than apples do. So now I'm going to change my calling convention right here. Okay, you'll notice that my main is getting a lot simpler here. Basically, all I'm doing is using a different visitor to visit each individual element, and the specifics are being hid away in these different visitor classes. Okay, I have two more to do here. Let's do them both. This is getting a lot easier. Notice how the pattern is really emerging of what makes these things the same. All right, I have one more to do, and that one more is my count. Okay, now we're finished. So now we have our three types of fruit, oranges, apples, and plums. Now we're going to initialize them using the visitor. We're going to display them using the visitor. We're going to tally them up using the visitor. We're going to eat using the visitor, and then, of course, display and count one final time. When I run the code, it works exactly as I expect. Really, nothing has changed here. But now we're going to get into the magic of the visitor. Okay, so now we've created our visitor classes. Now we're going to have to modify the client. And the first thing we're going to do is we're going to create a fruit base class. And so then apples and oranges and plums are going to derive off this fruit base class. And then we're going to say, hey, client actually has a collection of fruit and it will no longer know about apples, oranges, or plums independently. Okay, I need to emphasize that just creating a fruit class and making everyone derived off it doesn't change a thing. The functionality is exactly the same. When I run it, I get exactly the same output, which we'd expect. But now what we're going to do is add a single method in our fruit-based class, which all the derived classes have to have. And this will be the one common denominator. And we're going to call this method update. Okay, by making this a pure virtual function, I am now required to implement this in each derived class, or I will not compile. If I attempt to compile, then I'm going to get these build errors. So we definitely don't want that. So let's make this implement update. Okay, now that I've updated these, when I run it, I now compile again. Yay, everything is successful. But now here's going to be the magic of the visitor. Okay, I'm going to go into the apple here and I'm going to say visitor. I'm going to call the visitor, but now I'm going to tell it exactly which version of visit I want. Dot visit apples. Okay, so now it's going to clue into that specific method in the visitor class. And what am I going to send? Star this because it's going to want an apple. And I know I'm an apple because I'm an apple here, so I'm going to send it an apple. Now I'm going to do this exact same function in my other classes as well, except in my oranges, I'm not going to say visit apples, I'm going to say visit oranges. And notice star this is now an orange. And now I'm going to do the same thing for visit plums. Okay, now that little difference here, this is the key sorry, not apples, but plums. Okay, this little line of code is the only connection now between plums and oranges and apples. And that makes all the difference in the world. So as a recap here, I have my visit apples, oranges, and plums in my visitor class. And now my fruit is going to have my single pure virtual function update. And now my apples is going to have an update, and my orange is going to have an update, and my plums is going to have an update. Okay, the last thing I want to do is I want to integrate this into the code. I'm going to go from the old version, which had to know specifically about apples, oranges, and plums, and the new version, which doesn't know about any of those things. It just calls update. And the same thing with true with when I have lunch, I'm just going to call the eat. And when I call display, I'm going to call visit display. So let's see how that works. Okay, initially I have a collection of fruit, but now I'm going to say that this is a vector. Instead of apples, oranges, and plums, I'm going to say vector of fruit star polymorphic, which is going to be my fruit. And then I'm going to say fruit dot push back, and I'm going to say new apples. And I'm going to do the same thing for oranges and plums. All right, now how am I going to fill my basket? I'm no longer going to have an apples, oranges, and plums. Instead, I'm going to say for auto F in fruit, and then I'm going to say fruit. I'm going to say init dot, I'm going to say fruit dot update. All right, so now I'm going to iterate through all elements of fruit. Now, the first one I'm going to do is apples, right? So it's going to call update for apples. And let's see what's going to happen here. It's going to call update for apples and it say, oh, I require visit apples. Now remember, this is initialize. So initialize is going to get called visit apples. And I'm going to pass star this, which is my apples. And I'm going to say, oh, set Honeycrisp, Fuji, and Macintosh red, and then return 0. And then it's going to do the same thing for my oranges and my plums. Now I'm going to do the same idea here for my display, except now I'm not going to update init, I'm going to update display. I'm going to do the same thing for display, except I'm not going to call init, I'm going to call display. Now, when I get the total here, I'm going to need to catch the return value, so this one's going to be slightly different. Now for eat, I'm going to iterate through everything just like before. Now I have to display, and one last total. Okay, let's run it to make sure I didn't break anything, and I get exactly the same output. Now, the thing I really need to emphasize about this whole thing, oops, sorry, I forgot to call count here. And now I have exactly the same output. Now, the thing I really want to emphasize is now my client, in this case, main, knows nothing about the interfaces of apple, oranges, or plums. In fact, every time I want to do anything, I want to send any message, I use essentially the same code. I have a for loop and I call update and then I pass the visitor in. Everything else is exactly the same. You can learn more about the visitor in the visitor section of the message passing chapter of the software design textbook.